get started on your day 2 notes over another introduction to geometric proofs. We're talking about angles again today, but we are going to be proving and using some theorems. You can refer to your geometric proofs reason bank. In addition to all the definitions and everything that we have previously talked about in the previous lessons, we are going to be using the definition of a right angle as a justification today, which tells us that if an angle is a right angle, it measures 90 degrees. We're also going to be using the definition of a straight angle, which tells us that if an angle is a straight angle, then it measures 180 degrees. We are not going to be using the definition of adjacent angles today, but you will need to know it, and you can just refer to that, go over it. Definition of a linear pair. This tells us that if a pair of angles is adjacent, whose non-common sides are opposite rays, the angles form a linear pair. It's just two angles that basically added together form a straight line. We're also going to be using the definition of vertical angles. So two intersecting lines, they're across from each other. We're going to be proving theorems. What is a theorem? A theorem is any statement you can prove. Once you prove a theorem, you can use it as a reason in later proofs. And in today's lesson, you will prove and use the following theorems. So let's go over the theorems that we're going to prove. And again, some of these things you probably know, but you know, when we're proving other geometric things, other properties and definitions, then we might have to use these theorems within those proofs. The linear pair theorem. This tells us that a linear pair of angles is supplementary. Okay. If they're supplementary, then by the definition of supplementary angles, their measures add up to 180 degrees. So we can go from, like, in our chain of steps, we can say, okay, the linear pair theorem tells us that these two angles are supplementary, and then the definition of supplementary angles tells us that their measures add up to 180 degrees. That's kind of your thought process, right? The vertical angles theorem. This just tells us that if two angles are vertical angles, then they are congruent to one another. So angle A is congruent to angle B because they're vertical angles. The congruent complements theorem. This tells us that if two angles are complementary to the same angle, then those angles are congruent. So, for example, if 1 and 2 are complementary and 2 and 3 are also complementary, then 1 is congruent to 3. Angle 1 is congruent to angle 3. They're complementary to the same angle. Likewise, the congruent supplements theorem is similar to the congruent complements theorem, but they are supplementary angles. So in this example, you have angle 1 is supplementary to angle 2, and angle 2 is supplementary to angle 3, which means that angle 1 is congruent to angle 3 because they're supplementary to the same angle. The right angle congruence theorem tells us that all right angles are congruent. So if A and B are right angles, then angle A is congruent to angle B. So let's prove these theorems. And again, like I said, you probably know all of this. Like, okay, if you have two right angles, then obviously they're congruent to one another. But well, we have to actually prove that. So you've learned it, but here's our proof. And once we prove it, this theorem, then we can use that theorem as a reason in later proofs. Let's get started on example number 1. Let's see, I think we have 6 examples to do today, and I'll try to go through these fairly quickly. In this first example, we're going to prove the linear pair theorem. We're given that angle 1 and angle 2 form a linear pair. And we can visually see that, right? Those two angles are next to each other. They form a linear pair. And we are given this. By the definition of a linear pair, okay, that says the definition of a linear pair, opposite rays, which BC right here, and ray BA form a line. They're a pair of opposite rays. Golly, I've got to erase that. That is just like so ugly. Sorry about that. Okay. All right. So I'm going to use blue again. So ray BC and ray BA form a line. That's a definition of a linear pair. Now, the definition of, oh, whoops, I just kept going, didn't I? The fact, statement number 3, says the measure of angle ABC is 180 degrees. We can visually see this is a line, right? We've got BC and ray BC and ray BA form a line. So that's a linear pair. Well, the linear pair right here, or this angle, this entire angle is a straight line, which means its angle measure is 180 degrees. So I can say, and I have it there as my clue, that the measure of angle ABC is 180 degrees, and we know that by the definition of a straight angle. Our next clue in our proof says the angle addition postulate. Okay, well, let's form an equation based on that. Okay, well, we know that the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. It's the whole thing. Again, I can name an angle, like I could say the measure of angle ABD plus the measure of angle DBC. I could do that, but since I have numbers already in my problem and I have numbers up here in my given and proof, let's go ahead and use those. So now we have an equation, and let's see, I like to maybe replace parts of that equation with numbers, but I can only do that if I've already established something in my proof. Here I have established that the measure of angle ABC is 180 degrees. So I can replace that right here in my next step. The measure of angle 1 plus the measure of angle 2 equals 180 degrees, and I know that by the substitution property. And again, you can say substitution property of equality, you can say substitution property, you can say substitution POE. I sometimes just see substitution. So now, how do I get to this last step? How do I get to this right here? We are proving that they're supplementary. We get that when I add the two together, the angle measure is 180 degrees. So I can say that angle 1 and angle 2 are supplementary by the definition of supplementary angles. So this is a proof of the linear pair theorem. There's all these steps. Okay, there's 6 total steps that I get from right here, which is that angle 1 and angle 2 form a linear pair, to right here, which tells me, okay, they're supplementary. Now I can use this linear pair theorem in later proofs when I want to jump from the fact that if I see 2 angles form a linear pair, okay, by the linear pair theorem, I know they're supplementary. Let's show that in example number 2. We're given that angle 1 and angle 2 are congruent. Let's write that down. Angle 1 and angle 2 are congruent. We are given that. We now need to prove that angle 1 and angle 3 are supplementary. Okay, so let's get started. Angle 1 and angle 2 are congruent. Well, what do I know about their angle measures? I know they're equal to each other by the definition of congruent angles. So you can see I have a little clue in step number 3. I have the linear pair theorem already written there, which tells us that if 2 angles form a linear pair, then they are supplementary. Well, I know that angle 2 and angle 3 are supplementary by the linear pair theorem. Okay, so tell me about supplementary angles. Well, if I add them together, I get 180 degrees. The definition of supplementary angles tells me that. Okay, so again, we are trying to prove angle 1 and angle 3 are supplementary. I can write that down at any time. I can write that down. That's what I'm trying to get to. I've got the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Okay, but I'm trying to get to the fact that angle 1 and angle 3 are supplementary, not angle 2 and angle 3. Oh, wait. Look what I've established up here. That the measure of angle 1 equals the measure of angle 2. Okay, so can I replace the measure of angle 2 with the measure of angle 1? Sure, I can do that using the substitution property of equality. Then, let's erase this. I get to that angle 1 and angle 3 are supplementary by the definition of congruent angles. So example 1, we proved the linear pair theorem, which takes me from the hypothesis that if angle 1 and angle 2 form a linear pair, to the conclusion that then angle 1 and angle 2 are supplementary. And we proved that using all of these steps. But now I don't need to write all of that mumbo jumbo in between in a different proof. I can just use the linear pair theorem as a reason. Let's prove some more theorems. The next theorem is the congruent supplements theorem. So the congruent supplements theorem, angle 1 and angle 2 are supplementary. So we can see that angle 1 plus angle 2, well, okay, we're just going to say they're supplementary, right? We know when we add them together, we get 180 degrees, but we can't just jump to that. But we know that about supplementary angles. And angle 1 and angle 3 are supplementary. Okay, so we know that these two sets of angles are supplementary, or we know that angle 2 and angle 3 are supplementary to the same angle. And we're asked to prove that angle 2 is congruent to angle 3. Okay, I've written down the givens for you. Given is the reason. Okay, we're trying to prove, and let's write this down. Angle 2 is congruent to angle 3. Okay, how do I get from step 1 all the way to step 5? Okay, well, I know that by the definition of supplementary angles, right? Because if we're given a vocabulary word in our given, let's define it. Well, I can say that if they're supplementary, then when I add those two angle measures together, I get 180 degrees. So because we're given two sets of information, like angle 1 and angle 2 are supplementary, I can write one equation here, and angle 1 and angle 3 are supplementary, so I can write another equation here. And I can just write that in the same step, and I use the reason as that's the definition of supplementary angles. So you might see that I have it color-coded. And I have it color-coded so you can visually see that I have these two expressions that are equal to the same thing. Okay, well, if they're equal to the same thing, then can I set them equal to each other? Sure. That's the transitive property of equality, right? If A is equal to B and B is equal to C, then I can say A is equal to C. So if measure of angle 1 plus measure is 180 degrees, and then 180 degrees equals that, then I can set those two equal to each other. So what can we do now? This says the subtraction property of equality. I've got a little clue here. Okay, well, I'm trying to get angle 2 and angle 3 by itself on each side of the equal sign. Can I subtract the measure of angle 1 from both sides to get the fact that the measure of angle 2 is equal to the measure of angle 3? And then, let me erase because I wrote that down. And then if angle measures are equal to each other, then the angles are congruent by the definition of congruent angles. So here's a proof of the congruent supplements theorem, which tells us that if two angles are supplementary to the same angle, then those angles are congruent. Well, now I have the congruent complements theorem. And notice down here, I have 5 steps, just like I did in this proof in example number 3. Everything's the same, except instead of supplementary angles, we're going to be looking at angles that are complementary. Let's do this. Complementary angles right here. It tells us angle 1 and angle 2 are complementary, and angle 1 and angle 3 are complementary. We're trying to prove that angle 2 is congruent to angle 3. Well, first, we've written our givens down. These two angles are complementary. These two angles are complementary. These two angles are complementary to the same angle. Therefore, they are congruent. How can I prove it? Well, If they're complementary, what do we know by the definition of complementary angles? We can come up with these two equations. When I add those two angle measures together, I get 90 degrees. When I add angle 1 and angle 3 angle measures together, I get 90 degrees. Now I have two expressions equal to the same amount. I can set those two expressions equal to one another by the transitive property of equality. Just like I did in example number 3, I'm trying to get measure of angle 2 equal to the measure of angle 3. How can I do that? I can subtract the measure of angle 1 from both sides of the equation, right? It's the same amount. I'm subtracting the same amount from both sides, and I'm left with the measure of angle 2 is equal to the measure of angle 3. What did I do to get there? I used the subtraction property of equality. If two angle measures are equal, then the angles are congruent by the definition of congruent angles. Let's move on. Last two examples, example number 5 and example number 6. Example number 5, we're gonna prove the vertical angles theorem, which tells us that two vertical angles are congruent, right? And so again, you know this. You probably learned this in like 6th or 7th grade, right? You were able to identify vertical angles and you knew they were congruent. Here's the proof of it. We are given that angle 1 and angle 3 are vertical angles. That's something that we're given, okay? We know, and that's always what we write first, right? Angle 1 and angle 3, we're asked to prove that these are congruent. Well, we know by the definition of vertical angles that angle 1 and angle 3 are formed by intersecting lines. We can visually see that angle 1 and angle 2 are a linear pair, and angle 2 and angle 3 are a linear pair. We can visually see that. Okay? What do we know about angles that form a linear pair? We know they're supplementary, right? We know that by the linear pair theorem. Remember, if two angles form a linear pair, we know that they are supplementary by the linear pair theorem, which we have already proven in example number 1. We don't have to put all that mumbo jumbo in between, like how we got from the fact that they're a linear pair to the fact that they're supplementary angles. We can just say, hey, if two angles form a linear pair, then they're supplementary angles. Boom. Why? The linear pair theorem. Okay, let's see what else. We have that angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. Wait a second. If two angles are supplementary to the same angle, right? 1 and 2, 3 and 2, what does that tell me? That tells me that angle 1 right here, oh gosh, let me erase. Let me do some erasing here. Maybe I'll use my highlighter. Okay, highlighter. That tells me that angle 1 is congruent to angle 3, right? They're supplementary to the same angle, which means they're congruent. And how do I know that? It's another theorem that we've proven. That's the congruent supplements theorem. That tells us that if two angles are supplementary to the same angle, then those angles are congruent. So here we use the linear pair theorem within this vertical angles theorem, and we use the congruent supplements theorem within this vertical angles theorem. So again, once you've proven a theorem, you can use it as a reason in later proofs. Pretty cool, huh? Okay. Let's move on to our final theorem. We're going to prove the right angle congruence theorem. We are given that angle 1 and angle 2 are right angles. Let's see, I need a pen right here. Angle 1 and angle 2 are right angles. That's something that we're given. So let's write that in our proof. And we're going to prove that they're congruent. And I know in your head you're like, well, duh. Like, I know it, of course. They're both right angles, so then they're congruent. No, in math and geometry, we need to create a chain of logical steps to show that they're congruent. But once we do this, we can use this theorem in later proofs to go, okay, if they're right angles, then they're congruent. Boom. Okay, angle 1 and angle 2 are right angles. I can then say that their angle measures are 90 degrees, and I know this by the definition of a right angle. And again, I've got my color coding going on, that I have two things that are equal to the same thing. Measure of angle 1 is 90 degrees, measure of angle 2 equals 90 degrees. Okay, they're equal to the same thing. Let's set them equal to each other. Now I can say that the measure of angle 1 is equal to the measure of angle 2 by the transitive property of equality. Why would it be equality instead of congruence? Right? Because I can say the transitive property of congruence, but I'm using the transitive property of equality because I've got an equal sign. I'm talking about their measures, right? I'm not talking about the angles being congruent. I have an equal sign. Their angle measures are equal. Well, I'm trying to prove that angle 1 is congruent to angle 2, not that their angle measures are equal. So I have one more step to show that if their angle measures are equal, then the angles are congruent, and that is by the definition of congruent angles. That concludes your day 2 notes. Over an introduction to geometric proofs, we talked about proving and using theorems involving angles. I hope it was helpful.